Hey everyone, and welcome. Today, we're diving into something that is the absolute foundation of Java, data types. Seriously, you can think of them as the DNA of your code. They're the basic building blocks for every single program you'll ever write. So yeah, understanding them isn't just important, it's absolutely essential. So let's kick things off with a simple question. How does a computer actually know that, say, the number 28 is something you can do math with, but Alex is just, well, text? I mean, at its core, it's all just ones and zeros, right? So how does it possibly distinguish between them? Well, the answer to that puzzle is something called a data type. A data type is basically a label. It's a classification that tells Java's compiler two really critical things. First, what kind of value it's looking at. Is it a number, a letter, a true-false thing? And second, what you're actually allowed to do with it. So here's our game plan for today. We're going to start with the two main families of data in Java, then we'll dive deep into the four essential groups of what we call primitive types. We'll look at how to handle whole numbers and decimals, then move on to characters and logic, and we'll wrap it all up with a super quick review of the rules you absolutely have to know. Okay, let's get started with the big picture. Every single piece of data you're ever going to use in Java, and I mean every piece, falls into one of two major families. So these two families are called primitive types and reference types. Think of primitives like individual Lego bricks. They're the simplest, most basic units of data, like a single number or a single character. Reference types, on the other hand, are the cool, complex things you build with those bricks. For this explainer, we are going to focus completely on mastering those fundamental bricks, the primitive types. Now, even within that primitive family, your tools are neatly organized into four distinct groups. Getting these down is like learning the must-have toolkit for any Java programmer. First up, we've got integers, and that's for all your whole numbers. Second, floating point, for any number that has a decimal. Third is character, which is for just single letters or symbols. And finally, Boolean, which handles simple true or false logic. Let's break each one of these down. We'll start with the group you'll probably use the most, integers. These are going to be your go-to types for any kind of whole number, whether it's positive or negative. But wait a minute, you might be thinking, if they all just store whole numbers, why does Java give us four different types for them? Why not just have one big universal number type? Well, the answer boils down to one simple word: efficiency. And this table right here shows us exactly why. Each of these integer types reserves a different amount of space in memory. A byte is teeny tiny, just one byte, perfect for small numbers where you want to save memory. An int is kind of the general purpose workhorse for most situations. And then you have long, the real heavyweight, using a full 8 bytes for truly massive numbers. The key takeaway here is just choosing the right tool for the job to make your code as efficient as possible. Now, here is a critical rule you absolutely have to remember. When you're using the long data type, you have to tell the compiler it's a long number by adding a capital L at the end. If you forget that L, Java's going to think you're trying to cram a giant number into a regular int, and it's just going to throw an error. All right, next up, let's talk about numbers that aren't whole. You know, anything with a decimal point. For these, Java gives us two main options in what's called the floating point group. We have float, which is smaller, and double, which is larger and gives you more precision. Now here's a really critical detail you need to burn into your brain. In Java, double is the default for any decimal number. And this one little fact leads to a super common mistake that trips up almost every single beginner. So let's look at that mistake. You might declare a float variable and try to set it to 3.14. Logically, that seems totally fine, right? But it'll give you a compiler error. So why is that? Well, it's because Java automatically sees any number with a decimal as a double, and it won't let you try to pour a big double value into a smaller float container without your permission. Thankfully, the solution is easy, and it's just like what we did with long. You just have to add a suffix. This time, it's a capital F at the end of the number. This basically tells the compiler, hey, I know this looks like a double, but trust me, I want you to treat it as a float. That one little letter makes the error go away. Okay, so we've covered numbers. Now let's move on to our last two primitive groups. These handle single characters and simple true or false logic. First up is char, which is just short for character. Now, here's something that's actually really interesting about Java's char: its size. In a lot of other programming languages, a character only takes up 1 byte of memory, but in Java, it takes up 2. And this slide explains why, and it's actually pretty brilliant. See, older systems used a standard called ASCII, which was fine for English and some symbols, but it couldn't handle characters from other languages. Java uses a much more modern standard called Unicode. That extra byte gives Java the power to represent characters from pretty much every language on Earth, which really makes it a global programming language. Here is another one of those absolute rules you just have to memorize. When you define a char, the character itself must be inside single quotes. Double quotes are saved for a totally different data type called a string, so if you use them here, you're going to get an error. Remember, single character, single quotes. Our final primitive type is actually the simplest of them all, Boolean. Its only job is to represent logic. A Boolean variable can only ever be one of two things, true or false. That's it. It's the foundation for all the decision-making in your code. Now, a quick point of clarification, especially for those of you who might have used other languages. In Java, a Boolean is not a number. You can't use 1 for true and 0 for false. You have to use the actual keywords true and false. The compiler does not see them as the same thing. Okay, I know that was a ton of information, so let's lock it all in with a quick-fire review of the most important, must-know rules, the kind of stuff that will definitely show up on exams or cause bugs in your code. Let's drill these in. Rule 1, Java's default for any decimal is double. Rule 2, float values need an F at the end. Rule 3, long values need an L at the end. Rule 4, char values always use single quotes. And Rule 5, Boolean is only ever true or false, never ever 1 or 0.
And there you have it, the fundamental building blocks of data in Java. These primitive types, they're like the atoms that you're going to use to build every complex program from here on out. You now have that foundational toolkit. So the only question left is, what are you going to build?